Hello, so in this video I'm going to walk you through how to determine what type of front you have on a map, um, and we're going to specifically be using maps that have the front location already given to you. So the maps that we're going to use are similar to what we've used in previous labs. So we're going to be using station models on the map to help tell us what's going on weather-wise. So if you need a recap of what station models tell you and what data is where, definitely check out that video from a few weeks ago. You can find it in weeks 1 and 2. I also had a video walking you through the map as a whole and what it looks like, so you can check that out if you need to. It will also be helpful to review what the types of weather fronts are and also what type of weather is associated with each one. So I talk about these in the lecture videos for this week. The National Weather Service jet stream web links that I have in the lecture page also will help, and there are some great tables in your textbook. So we're going to focus here on how to identify fronts on a map. So this is an example of one of your lab questions. So you got your weather map here. You see your isobars in the kind of lighter lines labeled 976, 980, 984, 988, so on and so forth. And these bolder lines here, those are your weather fronts. So to determine what you have for fronts here, we're either going to have cold, warm, occluded, or stationary. So the key here, first of all, is to see if these fronts are moving at a fast rate. So I'm just going to take my pen here and we're going to draw on the map arrows to help us with our air motion. So if we look at the wind, this tells you, the little wind arrow here tells you the direction the wind is coming from. So I can basically make these into arrows. So we see the wind is moving in this direction for all of these for the most part. So we see air on the west side of the front is moving towards the east. If we go up here to the top one, we can do the same kind of thing. We see air moving to the north for the most part across this front. So we have an idea of which way these fronts are moving. The next step is to take a look at what the individual, and I'm going to try to use green here, temperatures are on either side of your front. So if we look over here, we've got a 54, a 45, we've got a 38. So if we look on the total opposite side here, we see a 59. I think that's a 55, a 68, a 71. So in general, when we compare across the front on either side, we have colder air on the west side, warmer air on the east side. So what this is telling us is if this air mass is moving to the east, we have cold air invading warm air, which would make this a cold front. So what we would do is change our color to, if I could do this right, to blue. And we would color this line blue and then make our blue teeth marks on the front, pointing us in the direction that the air is moving. So just like little arrowheads. So if we look at the top here and take a closer look at the temperatures again on either side, we have 46, 56, 62. Look on the other side and we've got 28, 43, 48. So in general, we have warmer air on one side of the front, colder air on the other. So the warmer air on the south side of the front is moving to the north based on our airflow arrows here. So this would be a warm front moving to the north. So we'd pick red and put our little half circles across those. So that's how you can tell, given the location of your fronts, what type of front you have on each of these. So you'll be walking through and doing this on your own in the lab this week. So if you want more information, there's some tutorial links as well, and information on the Jetstream website, how to read surface maps here, and you can go through and check out what each of those fronts mean and some other symbols that you might see on your weather maps. As always, let me know if you have any questions.